Hello everyone. Welcome to MRU E-Learning powered by Malla Reddy University. I am Tumala Lavanya, Assistant Professor from IT Department in Malla Reddy University. Today I am presenting the topic Understanding Deadlocks in Modern Operating System. So before knowing the deadlocks, we have the basic knowledge on resources. So what is a resource? In an operating system, a resource refers to any software or hardware components that can be allocated for process execution. For example, I need to take a documentation printout. For that, I need the resources, that is a system and printer. So to complete the task which we are required, hardware or software, those are called resources. These includes CPU time, memory, storage space, I/O devices, and network bandwidth. Since the resources are limited and often requested to multiple processes simultaneously, the operating system acts as a resource manager to ensure fair, efficient, and secure allocation. A mathematical representation to determine if deadlock has occurred. So the graph contains nodes and vertex, and edges. Vertex processes P1, P2, P3 and so on. And resource types are R1, R2 and so on. So edges are Pi to Rj and Rj to Pi. An arrow from the process to resource indicates requesting the resource, and an arrow from resource to process shows an instance has been allocated to the process. Process is a circle and resource type is a square. So inside the resource, the dots represent the instances of resource type. Suppose I am having the same type like a printer. I am having 4 printers. So the resource type is same and the instances here I am having 4. So the type is represented by dot. So now coming to the deadlock. A deadlock is a situation in a computing environment where a set of processes get permanently stuck because each process is waiting for a resource held by another process and none of them can be processed. So how the deadlock occurs in OS? A process in an operating system typically uses resources in the following sequence. First, we need to request the resource, and after requesting, it will allocate the resource, then use the resource. So after completing the process, we can release the resource. So we will consider the general example, bridge crossing example for the deadlocks. Suppose traffic in only one direction. Each section of a bridge can be viewed as a resource. If a deadlock occurs, it can be resolved if one car backs up. So several cars may be backed up in deadlock situation. Deadlock will be occur. So starvation is also possible. So coming to the example deadlock. Deadlock arises when process hold some resources while waiting for others. Here P1 holds resource R1 and R1 requested to R2. Process P2 holds the resource and R2 request for R1. Neither process can be proceed, causing a deadlock. So in this graph also, if the graph contains no cycle, then no process is deadlocked. If there is a cycle, then a resource have multiple instances, there may be chances for deadlocks. If the resource type has only one instance, then deadlock occurred. In this diagram, P1 requested R1 and R1 requested P2. P2 again requested R3 and R3 is requested assigned to P3. So P2 is requested R3, R3 assigned to P3. So this is the deadlock situation. And in this graph also, if there is a circular like P1 holds R1, R1 holds P2, again P2 request R3, R3 requested P3 and P3 requested R2 and R2 again assigned to P1. So here we can see the circular So this is the deadlock situation. In this graph, there is no deadlock situation. There is no cycle. So the necessary conditions for deadlock in operating system. Deadlock can arise in the following 4 conditions hold simultaneously. So what are the 4 conditions? Mutual exclusion, hold and wait, no preemption, circular wait. First, coming to the mutual exclusion. Only one process can use a resource at a given time. That is, resources are non-shareable. For example, we are having a small tunnel. In the tunnel, at a time, we can pass only one car can be passed through that tunnel. So, the particular tunnel is called resource and the car is called process. So, at a time, only one process can be executed. That is mutual execution. And next, hold and wait. A process is holding at least one resource at a time and is waiting to acquire other resources held by some other process. For this, we can consider that example of traffic signal. In the traffic signal, green color, if it is green, the roads are called resources. So, if it is green, then the only path is only one direction the vehicles can move. The remaining 3 directions has to be wait. So, the request second one is hold and wait process. And next third one is no preemption. A resource cannot be taken from a process unless the process release the resource. So, for this, what is the preemption? Preemption is nothing but we can't stop any process forcibly. So, whenever after the completion of the process only, the resource can be released. In the middle, it is not possible to release the resources. Circular wait. Set of processes are waiting for each other in a circular fashion. So, let us see example of circular wait. So, here we are having 4 process P1, P2, P4, P3, P4 and resources R1, R2, R3 and R4. P1 is holding R1 and waiting for R3. P2 is holding R2 and waiting for R3. P3 is holding R3 and waiting for R4. P4 is holding R4 and waiting for R1. Here we can form circle. So, none of the process can be executed. So, that is the circular wait condition. So, methods of handling deadlocks. There are 4 approaches to dealing with deadlocks. Methods of handling deadlocks. Deadlock prevention, deadlock awareness, deadlock detection and recovery, deadlock ignorance. So, first one is deadlock prevention. Prevention strategy. Already we are discussed the 4 conditions for necessary condition for deadlock. Before only we can prevent the 4 conditions, then there is no chance to occur deadlock. So, deadlock prevention is a strategy used in computer system to ensure that different process can run smoothly without getting stuck waiting for each other forever. We can prevent deadlock by eliminating any of the 4 conditions, eliminating mutual exclusion, eliminating hold and wait, eliminating no preemption, eliminating circular wait. So, first one is eliminating mutual exclusion. Some resources like printers are non-shareable, so this condition is difficult to break. However, we can share the files like read-only files can be accessed by multiple processes at the same time. So, here we can prevent the deadlock situation. For non-shareable resources, preventing through this method is not possible. Next, second one is eliminating hold and wait. There are 2 ways to eliminate hold and wait. By eliminating wait, the process specifies the resource it requires in advance so that it does not have to wait for allocation after execution starts. For example, process 1 declares in advance that it requires resource 1 and resource 2. By eliminating hold, the process has to release all the resources it is currently holding before making a new request. For example, P1 must release R2 and R3 before requesting a resource 1. So, eliminating no preemption. No preemption means resources can't be taken away once allocated. To prevent this, process must release resources voluntarily. A process gives up resource once it finishes using them. Avoid partial allocation. If a process requires resources that are unavailable, it must release all the current held resources and wait until all required resources are free. Next, eliminate circular wait. Circular wait happens when a process forms a cycle, each waiting for a resource held by the next. To prevent this, impose a strict ordering on resource, assign each resource a unique number. Process can only request resource in increasing order to their number. Next one is deadlock avoidance. Deadlock avoidance is a method where the operating system makes decisions dynamically to ensure the system never enters an unsafe state. Thereby avoiding the deadlocks is possible. Deadlock avoidance is mainly relies on algorithms that check resource allocation before making the decision. There are two common type of algorithms are there, Banker's algorithm and resource allocation graph. So in Banker's algorithm used when multiple instances of resource exist. It stimulates allocation and ensures that the system remains in a safe state before granting the resource. Resource allocation graph used when each resource have only one single instance. It checks for cycles in the graph to avoid the unsafe state. Next one is deadlock detection and recovery. Deadlock detection. Deadlock detection periodically checks for circular waits and resolves deadlocks by aborting and restarting the process, releasing the resources. It allows unrestricted resource access and immediate request fulfillment, enabling online handling. The main drawback is potentially loss due to prevention. Deadlock recovery. Deadlock recovery is the process of handling the deadlock after it has occurred. It involves process termination, resource preemption. In process termination, aborting one or more process for that which process has occurred the deadlock that will break the cycle. In resource preemption, temporarily taking the resources from some processes and reallocate them to the others. Next, deadlock ignorance. In the deadlock ignorance method, the operating system acts like a deadlock never occurs and completely ignores it even if the deadlock occurs. This method only applies if the deadlock occurs very rarely. The algorithm is very simple. It says, if the deadlock occurs, simply reboot the system and act like deadlock never occurred. That's why the algorithm is called ostrich algorithm. Thank you.